So, most of the time when you learn about the equations of a line, you learn them one at a time and you learn them completely separate from each other. Well, I'm going to do things a little differently today. This is a lot. This is a big lesson, but I really think if you keep your mind open and allow yourself to perhaps be a little confused, that it will start to make a lot of sense by the end of it, okay? And it'll help you see how connected linear functions are to each other. So this is the title, How to Derive the Equations of a Line from the Slope Formula. And why do we want to do this? Because it helps us really understand how all of the forms of a line are the same equation. They are different forms of the same function. So, what do we know about linear functions so far? Well, what we know is that we can plot 2 points on a coordinate plane, and we can connect them. And when we do that, we get a line. We also learned that we can calculate the rate of change or the slope of a line using the slope formula. Well, this is great and everything, but unless you specifically limit the length or, the length of a line by making it a segment like this, you know that lines go on forever towards infinity in both directions. So what if we wanted to find out for any given x, like say when x was 15, what's the y coordinate? What am I looking at? Well, you have to have an equation to do that. Well, guess what we can do with the slope formula? Is we can use the correct math term is called derive. We can derive the equation of a line from the slope formula, and this is how that works. So, to derive an equation that is a correct math term, we use our literal equation skills, all right? Now, right now, you can see that this formula is solved for slope. It's designed so that if we have 2 points on a line, let's remember that, x2, y2, and x1, y1, that's all we need to calculate the slope. Well, guess what? It's not only all you need to calculate the slope, it's all you need to find every piece of information about that equation. You can find the equation of that line. And this is how this works. So since we normally solve equations for y, then we need to get y all by itself. But right now you can see that y is being divided by x. So let's multiply by x on both sides. How can we do that? Well, you know that if we plugged values in for this would just be a number. X would just be one number and y would just be one number. We've been doing it for the past couple of days. So let's rewrite. So we've got x2 minus x1. And then over here, we've got y2 minus y1 divided by x2 minus x1, right? So when we multiply, we get to cross those out. On the other side of the equation, we have to do the same thing, right? So here we go, x2 minus x1. After rewriting this, behold, I present to you, class, this is the point slope equation for a line. From the slope formula. But let's look at this a little closer. And I know that some of you have seen this formula, exact formula, in textbooks, and they use it all the time. But I'm going to challenge you guys because I think you can handle it. Algebra 1 is the only class that you really see this particular type of terminology. Some college textbooks use it, but not that many anymore. Okay? It is far easier to write the general equation of this line using the same terminology and letters that you're going to use for every other math class that you take. So I invite you to take a walk with me and experiment a little. So I say that since this is the point slope form, that means we have the slope and we have one point. That means that our other point, since we're solving for it, right, we're going to plug in an x and we're going to get a y, that we are going to make x2 and y2, we are just going to rewrite them y and x without the fancy little sub letters, right? And I'm also going to invite you guys to give this a try. When you learn function transformations in Algebra 2, you get to know these two letters very well. They're our friends H and K. They mean X and Y. That's exactly what they mean, and that's all they mean. They mean this is a point, but it's a particular point. In this form of an equation for a line, H and K have a place. K, as you can see, is always connected to Y. H is always associated with X, always. So instead of Y1 and X1, I invite you to Y minus K and X minus H. And then I'm going to bend your mind a little bit further. Only in Algebra 1 are you taught that slope is m. Sorry about that. Okay, once you get out of Algebra 1, they use a different letter for slope, A. Okay? And I invite you to try this on for size. It's going to take a little while to get used to this, but I guarantee you that you're going to be very happy when you finally learn it, because what you're going to see next semester in our quadratics unit is this form of a line is going to show up. You're going to see it again with h and k. And then when you do exponential functions, you come up with this form of an exponential, this form of an absolute value, this form of a rational equation. All of them, they all use this exact structure. Okay? And you get to learn what these letters do. But the cool thing is that they never change. So I'm going to try to use this terminology for you guys right now. So let's finish up. Let's move this equation to another page, and I'm going to finish it for you, and then we'll move to the next video for practice. So here we go. We have y minus k equals a times x minus h. Okay? So if we were going to simplify this, I'm going to show you, remember, this is the point slope form of a line. But we can simplify this. I'm going to change colors to do it. If we wanted to just isolate y, which is what you should do, then we would add k to both sides. Okay, cross it off here, add it here. All right, and then we would have y equals a times x minus h plus k. Watch this. If we're just simplifying now, do you see that that's all I'm doing? I'm just playing the literal equation game. I'm simplifying this. So let's go ahead and do it. So now I've got y equals a times x minus ah plus k. So finally, for my final trick of the day, I want you to watch this. These two are constants. They always are. And you would combine them. You would add them together. Okay? So if we added them together, so what if I told you that negative a times h plus k equaled b? And what if I told you, let's go back to what you learned in Algebra 1, or the way that they taught it to you in middle school math, that that m was slope. So let's substitute, and what do we have, ladies and gentlemen? We have the slope-intercept form of a line. This is equivalent. You saw me. I just simplified the point slope form of a line, and I ended up with slope-intercept. All the same. No difference. So in the next video, we are going to write this down, and we're going to practice.